And a logarithm. Let us look at example 2. So in our example 2, we have the question says find the logarithm of each of the following. So part A, the number we have, find the logarithm to base 2 of 8. So logarithm of 8, but the base is 2. So in logarithm to base 2 of 8, we begin with solution. So under solution, we have the work below here. So in this one, under solution, we start by saying let the log to base 2 of 8 be equals to p. So in this example too, we are using the second method where we represent the logarithm of that number by some letter or some symbol. So in this case, preferably, I want us to use P to represent, but you can represent it with a T or K or Q or theta or any kind of things just to help you find the answer easily. So since the logarithm to base 2 of 8 is here, so we just say let the logarithm of that one, let the logarithm of that number be equals to P. So let logarithm to base 2 of 8 be equals to P. So that we can go ahead and say this implies that P is equal to log to base 2 of 8. So we rearrange. The one on that side, we turn it this way. The one on the other side, we turn it this way. So we have just rearranged this one to give us this one here. So log to base 8 of P, we know it is the same as log to base P of, we know it is P. It implies that P is equal to log to base 2 of 8. So as we start, we say log to base 2 of 8 is equal to P. So this implies that P is equal to log to base 2 of 8. So that in this case, we factorize this 8. We factorize this 8 using ladder method as we have indicated it here. So when we factorize, we divide in each step, we divide that number by the base of the logarithm. So since the base of the logarithm is 2, so in each case, in this ladder method, we are going to divide in each step by 2. So that is why we are putting this 8 here. So that 8 divided by 2, we get 4. And this 4 divided by 2, we get this 2. And also 2 divided by 2, we get 1. Now, since we have factorized it completely, now we know that this 8, which is here, is the same as this 8, which is equals to 2 to power 3. 2 to power 3. We are saying 2 to power 3 because when we divide this 8 in each step by 2, we know that we divide it 3 times for it to be completely. So the first one we divide by 2, next one by 2, next one by 2, then we get 1. So which means 8 is the same as 2 to power 1, 2, 3. So this power is supposed to be 3. Power here is supposed to be power 3. So that instead of writing 8 in our logarithm, instead of writing this 8, we just write the expression which is 2 to power 3. And you write that. But what we have done at the side here is the side work. You can even decide not to include it in your work. But what we want to see is that you should be able to convert this 8 to power form. But when you're converting, you divide in each case by the base. So that next time when we get 2 to power something, the base and the logarithm in front will be the same to make us easily convert it to 1, because when the base is the same as the logarithm, so automatically that number becomes 1. So 8 here is same as 2 to power 3. So that is that. So let us move to the next step. In the next step, we know that we have log to base 2 of 3 out of 3. And you know when the power, when the logarithm is having the power, the other power, we bring it down here. As it is indicated in the law of logarithm. So what we are supposed to do there, it is what we have already done here. So the 3 has come down, the 3 is now here. So the rest remains as being log to base 2 of 2. So in the next step, we know that we have now 3 into bracket log to base 2 of 2. So here we have introduced the bracket so that we can easily deal with what is in the bracket separately. To make it easy now to understand what has been done. So that's why we have put the bracket there to help us simplify our work. So now when we come up, the next step will now be, because we know that log to base 2 of 2, when the base is same as that number in front there, it must be 1. So for that matter, we can come up here and see in the next step what we have done. It is now here. So in this one, we know that log to base 2 of 2 has been converted to 1. So now we can open this bracket. And now when we are opening this bracket, we know 3 times 1, we get 3. And our 3 is down here. So therefore our P is equals to 3. So that is for example 2, part A. So let us go to example 2, part B, because part A is finished. So part B is here. In our part B, we have B, number is saying log to base 3 of 81. So in this one, we go to solution straight away. Then we say let log to base 3 of 8 be equals, let log to base 3 of 81 be equals to P. So this implies that our P is equal to log to base 3 of 81. So that we can now factorize 81. When we write 81 in factor form, it will be 3 to power 4. It will be 3 to power 4. You can use ladder method and find that. So that since we have here as being 3 to power 4, and the number is again having the power. So what we do, we consider 3 to power 4, and since this 3 is also having power 4, what we do, we bring the 4 down here. When you bring 4 down here, it will bring us to the next step here. And in the next step here, we know we have 4 log 3 of 3. So that is it. So now we can consider, we know log to base 3 of 3 is the same as 1. That is why 1 is here in the bracket now. So that when we are opening bracket, we might multiply what is in the bracket with the 1 outside, which is 4 times 1. Then we get 4, which is down here. So therefore, our P is equals to 4. So that is the answer for part B. And let us go to part C. And in our part C, we can begin with the NB here to remind us. So NB is saying a log without a base is a normal log. And when we say normal log, it means it is log 10. It is log to base 10. The base must be 10. So always when you don't see the base of logarithm, just make sure you put 10 there. So any log without the base, it is a base 10. sometimes call it normal log. And that is relevant to our example 2, part C. This part C you are seeing here. So what we do, we begin by saying log 1000. In log 1000, we just go ahead and write our solution. Then we say let log of 1000 be equals to P. So this implies that P is equal to log 1000. And since log 1000, we know 1000 here, we can write it in power form. So let us convert this one in power form. That's why we are saying back. Now, log 1, this one we know, log 1000. And we are supposed to put here log 1000 is the same as log to power 10 or 10 to power 3. So in other words, we can ignore this side work because of this one, but you should do your side work, because when you divide by ladder method, you put 1000, then you divide by 10. In each case, since it's normal base, it is a normal log. Here we shall have 100, so that when you divide by 10 again, you get 10. And when you divide by 10, you get 1. So this will imply that 1000 will now be equal to 10 to power 3 as the one we have indicated down here. So that is that for the next step, and that is bringing us to 1000, which is the same as 10 to power 3. So we can now find log 10 to power 3. So log 10 to power 3, we can isolate them by putting them in the bracket so that we can clearly see that. And now we know that. We know that we are saying that, but log to power 3 is the same as log to base 10 of 10 to power 3. And that is why we have put the base in the bracket. Though the base is not outside here, but we have put it inside there. Because when there is no base, it means the base is 10. So now, we know that when the base is the same as the log of that number, what we do, we bring it. Okay, it's the same as 1. When the base is the same as the figure in front, then automatically that number becomes 1. That is why in the bracket here we have 1. So 1 times 3 here, we shall get 3. And that is the answer for that number. So now, what we do, since we have finished part C, let us go to part D. In our part D, we know that we have log to base 4 of 64. So we go to solution, then we represent it by letter by saying let P be equal to log to base 2 of 64. So this 64, we have to factorize here by ladder method, dividing each step by the base of logarithm. Since the base of logarithm is 4, so each step we are going to divide by 4. So 64 divided by 4, we get 16. 16 divided by 4, we get 4. Then 4 divided by 4, we get 1. So after getting 1, we know that we have this 64, which we have indicated here, is the same as 4 times 4 times 4. We get all this by multiplying this 4 times 4 times 4. And since this 4 they are 3, is the same as 4 to power what? To power 3. So in the next step, instead of writing 64 now, we know that instead of writing 64, this 64, we know that 64 is the same as 4 to power 3. So since the power is here, we know that when the number in front of the log is having a power, we bring the power down here. So when they bring it down before log, here we shall have it as being 3, then multiplied by log to base 4 of 4. Log to base 4 of 4, we consider this one as separate, and since the base is same as a logarithm, we indicate it in the next step there. So now in the next step we can see that log to base 4 of 4 is now the same as 1. So now we multiply the 3 outside by 1 inside to open the bracket. So now our answer will be 3. So that is the answer for that number. And now let us go to the next, which is now the exercise. So this is a number you can try. After trying, you send me the answer in the comment. So the exercise says, work out the following. Part A, we have log to base 2 of 32. Part B, we have log 100. So what is the answer for part A and what is the answer for part B? What is that answer? Send me the answers. Thank you.